Hello, this is Mark E. Wilson, Dr. E. from La Cañada High School, coming to the last section of the air pollution unit, noise pollution, 7.8 noise pollution. The objectives here are to describe human activities that result in noise pollution and its effects. You'll be asked, one of the things that you can be asked is to describe the author's reasoning behind some writing and use evidence to support your claim. So what is a wave? Right here is a water wave. It's not noise, but it's a water wave, and this is what we're used to. The reason we wanted to show you is that in water waves, the molecules don't really move. They any distance side back and forth. They do not flow along the length of the wave. However, in a longitudinal wave, the particles, the individual particles, when you make a sound, it comes out of your mouth and it hits particles next to your mouth, air particles. Then those particles move a little ways away and hit other ones. Now you will notice that there are areas where there's a compression and a rarefaction. That is there so that it differentiates. It can be different tones, different frequencies and stuff like that. Now what's going to happen if it's your louder, higher frequency, these are going to be more pronounced, how much compression there is versus rarefaction. So loudness. Loudness is measured in decibels. Decibels, like deci means 10. A sound of 10 decibels is 10 to the first or 10 times as loud as 0 decibels. 20 decibels is 100 times as intense as 0 decibels. So can you tell me how much more intense is 100 decibels than 50 decibels? Correct, 10,000 decibels. If you count the zeros, there are 5 zeros there, and that tells you how much, the 5 tells you how many zeros. Going from 50 to 10 is 5 tens. So it would be 5 zeros in the number of times louder it would be. So source of sound and loudness. For example, when you can just barely hear something. When you just barely hear something, that is a threshold of 0 decibels. When you have a normal conversation like I'm having right now, that's somewhere around 60 decibels. Damage happens when you're around 85 decibels, amplified is 110, and if you're 30 meters away from a jet engine, that's 140. Definitely going to have damage unless you have headphones on. Now, one of the things I want to really talk to you about is that if you have earplugs in and someone else can hear your music, that is somewhere around 90 to 100 decibels. You can have ear damage. You can have hearing damage occur because it's too loud. Now, this is just looking at various levels. Breathing, what you're doing right now is 10 decibels. Refrigerator going is 40 decibels. Normal conversation is 60. Truck going by is 80. Construction worker or helicopter is 100. Loud concert is 130. I had a migraine after a loud concert one time. Eardrums will burst at 150 decibels. If you're near a shotgun, that would be 170. You can die if the noise is too loud. Well, urban noise pollution is any noise at a great enough volume to cause physiological stress, such as difficulty communicating, headaches, confusion, or hearing loss, such as construction, where jackhammers, trucks, or concrete pouring. Transportation, where you have cars, buses, or trains. Industrial activity like manufacturing plants, they can cause hearing problems. Domestic activity like your neighbor's music, not yours, but the neighbor's music, lawn mowing, home projects where you're using hammer, saw, and so forth, those can all lead to noise pollution. Now, wildlife effects. Noise pollution can disrupt animal communication, migration, predator or prey location, and it can damage their hearing. It can cause physiological stress. There's an experiment that's been done, and we'll see that in a second, where caterpillar heart beats faster when exposed to simulated highway noise pollution. It could lead these pollinators to die off. We can see here the number of heartbeats went from 60 to 90. When there was highway noise, it went from approximately 70 up to 85 beats per second, going from before to afterwards. Now, if there was no noise, it's no difference. Now, if they expose them again, it's basically the same thing, where there was an increase in the number of heartbeats, and a decrease or staying the same if there was no noise. If there is a chronic exposure, you can see that even without the noise, the number of heartbeats goes up. Hearing can prevent predators or prey from hearing each other. It can prevent mates from hearing each other, mamas from being able to hear babies, or babies from being able to hear mamas. Both of these decrease the chances of survival of the species. Aquatic noise pollution comes from the noise of ocean ships, engines, military sonar, fishing sonar, seismic air blasts from oil or gas surveying ships. So there's a physiological stress where there's hearing loss, disrupted ability to communicate, can't hear the mating calls, predator-prey navigation stops, predator and prey cannot see each other. Whales are especially prone to having migration routes disrupted as their vocal communication is disrupted. They use it to communicate with each other, to find fish, to figure out exactly where each other are. Seismic surveying ships send huge air blasts, these guys up here, huge air blasts down into the water while searching for oil or just basically searching for fish. This seismic blasting can be so loud that researchers off the coast of Virginia can detect the blast off of a ship off the coast of Brazil. You can see here where they send it down, and it just makes these whales or dolphins or others go crazy. So, practice 7.8 FRQ. Loud noises affect animals as well as people. Animals may suffer from hearing loss and experience stress due to noise pollution. Animal communication is paired around loud noise. Birds must alter their tune with higher notes or sing at different times. Bats have more difficulty finding their food because they use echolocation, and that is just disrupted in loud environments. Noise pollution is not only present in the air, it's also marine animals suffer from loud noises. Sound travels farther and faster in water. The sounds of propellers and sonar have interrupted the communications of whales and dolphins and caused hearing loss. Some marine whale pods have altered their migratory paths in order to avoid shipping lanes and areas of sonar use. Can you describe within this writing the reasoning behind the author's claim that whales may be able to adapt to the increased levels of aquatic noise and pollution? Thank you, and I hope that was helpful.